Good day, folks. Welcome to Bridesmaid Academy, where we bring brilliance to every lesson. In today's video, I want us to look at physical property type of question. Okay, so it says boiling points of organic compounds are compared. This is a dependent variable. Okay, we are trying to do what to see the boiling points of different compounds. So they depend. Remember, boiling point depends on chain. No. Yes, it depends on chain length. It depends on intermolecular force. It also depends on the branching. So we have butane here, 2.2 dimethyl propane, butane, pentane, and all of that. Define the term boiling point. The temperature at which the vapor pressure of a liquid is equal to the atmospheric pressure. Two or nothing. You get two or nothing for this definition. You get something incorrect. You leave temperature, you get 0. Anything that you miss, you get 0. 3.2, compound A and D are compared. A and D. Butane and pentane. Can you see now? They are of the same homologous series, right? They are of the same homologous series. They do not have any branching again. But now this one, it is but, it has 4 carbons. This one, it is pent, it has 5 carbons. So the independent variable here, it is chain length. What they are changing from A to D, what is it that they are changing? It is chain length. So this is my independent variable. Remember, I said the dependent variable is what? Boiling point. This is my dependent variable. Right? What is it that they did control? They controlled what? They are of the same homologous series. They controlled homologous series should be the same. Or if not homologous series, you can say functional group. Functional group, they are of the carbon-carbon single bond. Now, they say, write down the dependent variable. The dependent variable, I said it for this one, it is what? It is boiling point. Boiling point. Independent variable between now A and D, what is it that they are changing? This one had 4 carbons, this one had 5 carbons. What they are changing, it is what? Chain length. You can say molecular size, you can say what, it's fine. Control variable, it is now functional group. Or you can say homologous series. Or you can say type of intermolecular force, which are London forces. But remember, we find them from the functional group. They say 3.3 now. One of the learner argues that it will be unfair to compare, or it will be an unfair comparison to compare the boiling points of compound A and B. Let's look. A and B. Let's look at A and B now specifically. What is happening? A and B. A, it is butane, straight chain butane that has 4 carbons. H10. This one, it is 2.2 dimethyl prop. It has 5 carbons. It is something like this. 1, 2, 3. Then it has a branch on carbon number 1 or carbon number 2. 2 branches. Okay. Is it a fair comparison? No. Why? Because this one has what? C5H12. This one has now C5H12. And now remember. Oh, okay. Okay, it's fine. Let's look at this. Let's try to check the type of independent factor here. Homologous series, it is constant. Okay, type of intermolecular force is the same London force. Chain length, it is not. Okay, branching, it is not. So here it is not a fair comparison. Not a fair comparison. Why? Because we have 2 independent factors, which is a chain length and also branching. But here, if you had maybe something like this, it was going to be a fair comparison because it is what? C4H10. Okay, so we are going to say the independent factor here, it is what? Chain length or branching. Okay, but here it is both of them. Okay, here it is both of them. Branching, this one has a branch, this one does not have a branch. And this one has a shorter chain length, this one has a longer chain length. So we do not want that. We want what? One independent variable. So you'll say what? No. No. Why? Because now there are two independent variables. Namely what? Namely the chain length and branching. And another thing that you can say is that they have incomparable molecular mass. Incomparable molecular mass. Or the size is not the same. They do not have the same size. Can you see that? Unlike here, unlike A and D, can you see? Even though they are of the they have different molecular mass, but now they are of the same homologous series. Okay, they do not have branch, both of them. Okay, so branching is controlled, homologous series or functional group is controlled. What is not controlled, which is our independent factor, it is chain length. Can you see now? Yes. Then we come here, describe the trend of boiling points from B to C to D. B to C to D, what happens? The boiling point increases. Okay? Describe the trend, the increase in boiling point. Increase in boiling point. Sorry. Explain now the difference in the boiling point between B, C, and D. B, C, and D. B, C, and D. I want us to check. Between B and C, the difference is that this one has now another branch. So now, can you see this one has more branch, 2 branches. This one has 1 branch. This one has 0 branch. So now, and are they do they have now the same molecular formula? Because if the independent factor it is branching, they need to have what? They need to have the same molecular formula, which is what here it is pentane C5H10, methyl butane C5H10, also C5H10. So can you see the branching decreases as you go down, the branching again. And they also have what? The same molecular mass, like that. So you can say for 3.5, when we reason for 3.5, we're going to say all compounds have London forces, right? Oh, if from A to, from B to D, we are comparing from B to D. First thing, all compounds have London forces. The second point, from B to D, what happens? Branching decrease. Or you can say chain length increase. Okay? You need to say from B to D. If you do not say from B to D, you are out. Then if chain length increases, what happens to the intermolecular force? The type of intermolecular force present there increases. The strength of, strength of intermolecular force increases. When it increases, from where? From B to D. Therefore, what happens? More energy is required to do what? To overcome the intermolecular forces. That is that. Explain the difference in the boiling point. They all have London force, but from B to D, the branching decrease, right? Can you see the branching decrease? Or you can say now the chain length increase. Okay, but this one is the same. The reason here between A and B, between A and between yes, A and B, we couldn't compare them. It is because now branching or chain length is not the same, but now also molecular size is not the same. So now this makes it unfair. The molecular size should be kept constant. 3.6. How will the vapor pressure of butanol compare to compound E? What is compound B? Compound E, sorry. Compound E is butanol. Compound E is alcohol. Okay. Okay, and we know alcohol has a higher boiling point than butanol, but now we are talking about the vapor pressure. So this one, compared to this one has a higher boiling point, this one has a lower boiling point. So one that has a lower boiling point will have a higher vapor pressure. Remember vapor pressure, we say it is inversely proportional to boiling point. So how will the vapor pressure of butanol compare to that of E at the same temperature? Butanol will have a higher vapor pressure. Will have a higher vapor pressure. Why? Because it has a higher boiling point. Let's reason using, for 3.7, let's reason for that. 3.7, let's reason for that. Let's use appropriate reasoning for that. First thing first, you'll say butanol has dipole forces. And now what? E, which is butanol, or E, is it butanol? Yes. Has hydrogen bonding. You do not need to say one side of hydrogen bonding because you are not comparing carboxylic acid to alcohol. Therefore, you know that butanol has strongest intermolecular force. Therefore, more energy will be required. More energy will be required to overcome intermolecular forces, not to break, to overcome intermolecular forces, okay, of butanol. Okay, therefore, you are done. You can say temperature will be high, the boiling point will be high. Okay, but now these are the reasoning. First mark for saying this has dipole, hydrogen bonds. This one has a stronger intermolecular force, therefore more energy needed to overcome. Just like that. How easy is that? Very easy, right? Yes. So thank you very much for joining me. Let's meet on the next video. I hope you enjoyed.